So with Explore 3, we're thinking about the difference between a causal relationship and a correlational relationship. So if you're watching this, you've already done the short reading and the little intro video, which is just the first few minutes. So we already know, and we did the notes. So we already know some of the information here. Thinking about a correlational relationship, as it's described here and as in our notes, what we're thinking about is two sets of data or pieces of information that look connected and might be, but look connected on the graph. So almost all of our data is really going to be correlational because we're going to see a trend. If I see an increase or a decrease, if I see a trend is happening, I already know, okay, there has to be a relationship. They're connected somehow. The next step would be for it to then be a causal relationship. So a correlational, I already know it's there. Causal, when I think about those two data sets, now I'm thinking about two data sets that have a relationship, right? That trend, so it's just adding on to our other definition. But there's also a relationship or a causal factor. Also, one really makes the other happen. Right? And this will make more sense as we start to look at some examples, which you saw a couple in the video. Correlational, the one they gave was like the dog example or the test, right? Just because it's sunny out doesn't mean you're automatically going to get an A+ on your test. It just so happens that you also studied. So the fact that it's sunny is just a correlation when a trend with you doing good on your math test. A causal relationship might be the one mentioned up here is our Earth's climate, right? CO2 levels cause temperature to rise because of this idea of the greenhouse effect. They didn't really give a causal in the video, but they did give that one here in the reading. And that's what we're trying to find, these causal relationships, reasons that the climate is changing, what one thing is making the other happen. So you're going to investigate some of these down here, and it's a little step-by-step process as we go through these graphs. So the graph is already here for you. We first have to realize what we're looking at. So the X on this one is average temperature, and the Y is sea level at this certain location, Norfolk. So we're comparing temperature and sea level. Here's what I need to know. My background. Ice can't survive through the year in warmer temperatures. And when the ice melts, it has to go somewhere. That's the background I need to understand this graph. So first thing I look for is the trend. Do I see a trend happening? Now there's a lot of dots all over. So what we did in class was kind of played a little connect the dots. So just a really rough visual of connect the dots. While I look at that overall trend, I'm seeing definitely a trend, and that's going to be increasing. So first I look to see if there's a trend, meaning there has to be a relationship. If the trend is a yes, the relationship is a yes. So I can fill out my answer. As the average temperature increases, as the temperature goes up, my sea level, because it's increasing, also increases. So I'm getting my first two pieces of information from the graph. I'm just looking at it. Here's where it gets a little tricky. The last two ideas, 3 and 4, are not on the graph. I have to understand what data I'm looking at and what they mean to be able to decide if it's correlational or just correlational, or if it's also causal. So I can easily read the trend in the relationship from the graph. I have to determine my causal correlational based on what I know about those things. So, is one variable affected by the other? I'm looking at my background. Ice can't survive throughout the year with warmer temperatures. All the melted ice has to go somewhere. Does temperature control or play a role in sea level? So if it gets warmer, like it is on my graph, increasing, what will happen to ice? Well, ice will melt. If ice melts, it has to go somewhere. Well, where would that melted ice go? It's going to run off, it's going to infiltrate, ultimately getting to the ocean, the sea. That will change sea level. Does temperature have an impact on sea level? Yes, because as temperature is warm, ice melts. As ice melts, it becomes water, flows over the surface, and makes its way to the ocean. Yes, one impacts the other. Because one impacts the other, I know I automatically have a causal relationship. They were already correlational because I saw a trend in a relationship, but I took it to the next level and figure out their causal. Reading the background, knowing what I know about these things, one does impact the other. Let's do one more. Starting with, what am I looking at? I'm looking at average temperature, right? Mean means average. And I'm also looking at atmospheric CO2, or carbon dioxide in the air. Those are my two things I'm comparing. So I already know about temperature. I know CO2 gets into the atmosphere from combustion, comes out through photosynthesis, right? I know a little bit about it from last unit. So I'm starting up here, background. Carbon dioxide is a greenhouse gas which traps heat in the atmosphere. Okay, so carbon dioxide, CO2, traps heat in the atmosphere, so it keeps it in. So if it's keeping it in, that's probably going to have an impact on warming, right? So let's see what we've got. Do I have a trend and a relationship by looking at the graph? So here I've got my dots, and a pretty clear trend. Trend would be increasing. So I therefore know I automatically have a relationship. If I'm ever over here, like in the no trend, then there's no way a relationship can happen, and I'm pretty much done with the question, which is really nice. Atmospheric CO2 levels increase, so as I get more and more CO2, my temperatures are definitely also increasing with that trend. Now I have to think. I have to use my knowledge. I've already got my info from the graph. I got to do 3, 4. Are they connected? Does one affect the other? So carbon dioxide traps heat in. So can carbon dioxide control what the global temperature is? Yes, because it traps heat in. So if there's more CO2, it would trap more heat and the temperature would go up. So yes, there has to be an impact. Therefore, these are more than just a correlated pair of data. They are a causal pair of data where one makes the other happen. Okay? So there's a handful of additional graphs where you're doing that same thing. What do you have? What do you know about them? Read the graph, analyze. You're going to do that all the way to number 8. And then the last one here says pick one causal graph. So far, we know 1 and 2 are both causal. So you could do either of those or any of the other ones you find coming up. Once you find a correlational one, maybe you'll have some choices. Tell me how you know that's correlational. So you're explaining, right? How do you know? And then you are going to have some that also have no relationship, where I don't even see a trend. No pattern, inconsistent. Again, how do you know? All right, that's what we got going on here with our causal correlational explore number 3.